Hello, in this video I'll try to explain the interface and control of stepper motor pertaining to embedded controller lab. A stepper motor is a brushless synchronous electric motor that converts digital pulses into mechanical shaft rotation. Every revolution of the stepper motor is divided into a discrete number of steps. Usually there are 200 steps and the motor must be sent a separate pulse for each step. So this is how the structure of the stepper motor. The stepper motor consists four permanent coils and one moving coil. So the permanent coils is also called as starter and the moving coil is called rotor. So this stepper motor can be operated in two modes. The one is full mode and another one is half mode. In case of full mode, each starter can be energized separately. For example, if this is starter A, this is starter B, if this is starter C and D, then the sequence of energization is you have to energize A followed by B, then followed by C and then D. Thereby your that means stepper motor rotor, the stepper motor rotor will rotate in a clockwise direction. If you want to reverse the direction of the rotor, then the sequence of energizing these coils has to be reversed. That means you have to energize D followed by C and then B and then A. Thereby you can reverse the direction of the rotor. In full step, the rotor will take around 1.8 degree per step, because in order to complete 360 degree it requires 200 steps. Thereby per step the rotor will take 1.8 degree. So full mode sequence can also be operate like this, means at a time you can energize two coils simultaneously. So both are full mode sequence. By energizing two phases simultaneously, the torque of the rotor can be increased. Okay, this is about full mode sequence. So another one is a half mode sequence, in which let us consider the sequence where at one step we are energizing two coils. In the next consecutive step we are energizing only one coil. The next sequence the two consecutive coils will be energized. In the further sequence only one coil will be energized. Thereby the number of steps of the rotor can be increased or doubles as of the full mode sequence. In case of full mode sequence, a rotor takes 200 steps to complete one rotation, whereas in case of half mode sequence, this rotor will take around 400 steps to complete 360 degree rotation. Okay, so this is about the sequence for full mode and half mode sequence. Now consider the calculation. So the total number of steps is equals to total rotation angle divided by step angle. So in case of most of the stepper motor, the number of steps required to complete 360 degree is 200. So that means to complete 360 degree, if it requires 200 steps, then per step it's going to take 1.8 degree. So total number of repeated steps is equals to total number of steps divided by step sequence. Here the total number of steps is 200. The step sequence is 4, means we are energizing coil A, then followed by B, then followed by C and then followed by D. So in a sequence, that means in a step sequence there are 4 consecutive steps are there, so the step sequence become 4. So 200 by 4 become 50. Thereby the 50 times of step sequence are required to complete 360 degree. That means these sequences energizing A, B, C, D consecutively has to be repeated 50 times. Thereby you can complete one rotation, one full rotation, means one 360 degree rotation can be completed by the rotor. This is about the calculation of stepper motor. Now coming to the schematics pertaining to the lab. Again, stepper motor is a high load device. Your microcontroller alone cannot drive this. Thereby it is required motor driver. So we are now using a stepper motor driver ULN2803. The function of this is explained in the earlier video. Here the coils of the stepper motors, that means permanent coils of the stepper motors are A, B, C and D, and these A, B, C, D in turn connected to the A, B, C, D terminal of ULN2803. Those A, B, C, D pins are nothing but out 5, out 6, out 7 and out 8 of driver, and these are in turn connected to in 5, in 6, in 7 and in 8 consecutively. So the corresponding pins are input terminal 1, 2, 3 and 4. So we have to use these terminals in a connector. So the connector input terminal 1, 2, 3, 4 of connector A connected to 1, 2, 3, 4 pins. So the same connector at the microcontroller side is 1, 2, 3, 4. Consecutively it is pin number 4, 5, 6 and 7. Okay. Therefore, 4th, 5th, 6th and 7th pin of port 0 are used to energize the coil A, B, C, D in the stepper motor. So this is the port pin identification. If you give the sequence order to A, B, C, D via this 4th, 5th, 6th and 7th pin of port 0, then you can rotate the stepper motor in a sequential order. So the algorithm is as follows. You have to initialize the stepper motor pins 4 and 7 as GPIO, 4 to 7, that means 4, 5, 6, 7 as general purpose input output pins, and these pins must be directed as an output pin because your microcontroller has to send values to these pins, and you need to call the subroutine clockwise and anti-clockwise direction. In a clockwise direction, the sequence is energizing the coil A, B, C, D, but in anti-clockwise direction you have to energize the sequence from D, C, B, A. So the sequence is reversed in anti-clockwise direction. So you have to write two separate subroutines and you have to call those two subroutines and energize each coil separately in the desired sequence and energize the coils in the reverse manner to reverse the direction of the stepper motor. This is about. After this, as usual, you have to configure the required pin as general purpose input output pin. Here the pin identified as 4, 5, 6 and 7 of port 0. So these port pins has to be configured as GPIO. So the corresponding pin selection register must be chosen. Here since these pins pertaining to port 0 and since they are within 0 to 15, obviously you have to take pin selection 0 register. So the particular positions of this register has to be made 0, whereas the rest of the positions of the register must be padded with 1 and the obtained value is FF00FF. This value should be ANDed with the original value of the pin selection 0 register. Thereby you are ensuring only these 4 pins, that is 4, 5, 6 and 7th pin will be configured as GPIO and you are not affecting the functionality of the rest of the pin of port. Now after configuration of the selected pins as GPIO, you have to set the direction. Here all 4 pins are output pins. Thereby you have to use with the help of FIO-DIR, fast input output direction register, set the direction of those 4 pins as an output. So the corresponding register position is 4, 5, 6 and 7. Those positions must be made as 1, 1, 1, 1 and the remaining positions must be padded with 0. So the value is 0, 0, 0, 0, 0, 0, F0. So and this value should be ORed with the original content of the FIO-DIR register. Thereby you are ensuring only these 4 pins direction has changed to output and remaining pins direction will be unaffected. So this is about configuring those pins as GPIO and setting the direction of this pin. So these two values will be used in the program. And next, if you want to energize the coil in the stepper motor for clockwise direction, then you have to use the FIO set register and the corresponding pins are 5, 6 and 4, 5, 6, 7. Sorry, 4, 5, 6, 7 are the corresponding pins. So if you want to energize coil A, then you need to send logic 1 via 4th pin so that the corresponding value becomes 0, 0, 0, 0, 0, 0, 1, 0. And if you want to energize coil B, then you have to make the 5th bit of the register as 1 and remaining becomes 0. If you make 5th bit is 1, the value becomes 2. Similarly, to energize C, the 6th bit of the register should be made 1. Thereby the value becomes 4, and if you energize D, then the 7th bit should be 1, the value becomes 8. Okay, so this is the different values must be configured to FIO set register to energize the sequence A, B, C, D for clockwise direction. Similarly for anti-clockwise direction, so if you want to energize D, then the value becomes 8. For C, this is 4, and for B it is 2, and as well as for A is equals to A is 1. So these are all the different sequence has to be maintained to make the stepper motor, sorry, to rotate the stepper motor in clockwise as well as anti-clockwise direction. Let's consider the program. As usual, you have to include the header file. We are declaring global variables I and j. We are declaring functions, that is a delay function and clockwise subroutine or function and anti-clockwise subroutine, and this is the main function. The main program is initialized here. If any local variables you have to declare, after declaration of the local variable, these two standard functions has to be called. The one is system initialization and system core clock update. They are the standard CMSAS functions that's supposed to be called in order to update the clock values and PLL. Then after this, as usual, you have to configure the selected pins as a general purpose input output pin. This how this value got, that is discussed in the earlier slide, and this value must be logically ANDed with the earlier value of the pin selection register, so that only those pins, those 4 pins will be configured as GPIO and rest of the pins will be unaffected. And after setting this, you have to go for set the direction of those 4 pins with the help of FIO DAR register, and since these pins are pertaining to port 0, you have to use LPC underscore GPIO structure. So under that, this register value, original value of this FIO DAR register will be ORed with this value. Why this value is already discussed in the earlier slide. So these two statements will configure the GPIO pins, and as well as those GPIO pins will be configured as output pins. So this is a infinite loop where you are calling clockwise function as well as anti-clockwise function. So this is a delay routine. Now this void clockwise is a function, and this function has 4 repeated sequence. Means you have to energize coil A, then de-energize coil A, then you have to energize coil B, then de-energize coil B. There are 4 sequences, means 4 consecutive coils will be energized. So since this sequence consists 4 steps, we have to, in order to complete 360 degree, it requires 200 steps. So that's why 4 into 50 leads to 200. So therefore this sequence has to be repeated for 50 times. That's why we have took the count as j equals to 0, j less than 50, j plus plus, means this sequence will be repeated for 50 times. Now the LPC underscore GPIO 0 FIO set is equals to 0x000010. This instruction is going to send logic 1 via pin number 4th of port 0 in order to energize coil A. Now the same coil is going to de-energize by using the clear register. After A, we have to energize B, then after B we have to de-energize B, then you have to energize C. While between energizing coil and de-energizing the coil, you have to call the delay routine. Okay, this is the sequence has to be maintained in order to rotate the motor in clockwise direction. Okay, why this value? These values are the corresponding position of the pins, and which is discussed in the earlier slide. Similarly, we have another function called void anti-clockwise. Here just the sequence has to be reversed. Okay, so instead of energizing A first, you have to energize D, followed by C, then followed by B, and followed by A, so that your motor will, that means rotor will be rotating anti-clockwise direction. Okay, that's all about the program, and the demonstration video will be attached to the end of the slide. Thank you.